Hello, my name is Germán Corrales. I'm a senior researcher at Keysight Technologies, part of Keysight Lab. And today here we have a demo about AI and machine learning, where we are talking about the road to 6G. You know, in traditional communications, you have a transmitter, you have a receiver, and you have different blocks, right? You have synchronization, channel estimation, equalization, and so on. Today already in 3GPP, we have a lot of discussions about replacing some of these blocks with machine learning. And one of the questions is, why machine learning? Because basically we can actually have very optimized channel estimators for specific regions. So you can have, for example, a channel estimator that was really good in, for example, Barcelona, and you can have a different one in another city. You have the opportunity to really optimize, where if we humans need to do it, it's not really possible, right? So what we have here today is we are presenting a framework where you can actually implement some of these machine learning blocks in a simulation environment. We have a solution that is called Pathwave System Design. And in there, you can basically create an entire transmitter and a receiver chain. You can go all the way to power amplifiers, and then you can replace some of these blocks. And we actually done it in a way that you can actually bring your AI model and integrate into the design. So basically, you take one of these blocks and you remove it. So basically, you have AI in the loop. In the future, you will also see more about replacing not just one block, but multiple blocks. And even later, there will be AI talking to AI, right? So what we have here today? Today here we have a signal generator, which is connected to our software. We have a local oscillator that is at 23 gigahertz. It's been then here the signal that leaves our signal generator and goes to the up converter. We have a link that is running at 144 gigahertz, and we have a 1.5 gigahertz bandwidth signal. Then it's down converted and it's digitized, and it gets back again to our software. So in this case, what we are actually is measuring the performance of this AI model with hardware in the loop, with real signals going over the air at a very high frequency and a very high bandwidth. This is really what we are trying to assess here. So you have some bits that you want to transmit, you modulate it, you send it to the signal, go all the way through the testbed, and then we decode the signal and we give the pilots to the channel estimators. In this case, it's a collaboration with InterDigital, and they have developed a model, a machine learning-based model. They give us the channel estimation, we use it for our channel equalizer, and then we demodulate and we have the receive bits. So basically what we do is we compare the transmit bits with the receive bits. If they match, everything is good, right? So in here, we will not go that much into the details, but we are explaining how do you actually get started, how do you create your scenario in 5G, how you replace those blocks, how you actually integrate your model. And we are using the ONNX interface that was defined by Microsoft. So actually, you can bring a model from any place and plug it into our system view, and you are able to actually test it, right? So there are different parts in the training process where you need to identify where you want to have your probes. In this case, actually, we are interested about the pilots of the signal, and then you want to compare it with, for example, a traditional receiver. And this is what we are doing here, right? So the part of the training, you can actually do it outside using your normal software to do AI training. But at the end, the most important part is that you evaluate how things are working. This is really the key aspect, right? So in this case, first, you might want to start with simulations, purely based simulations, because the development is faster. Once you are confident that your algorithm is doing what you want, you can take it to the next level, which is, let's test it with hardware in the loop, which is the setup. And the very nice thing about the Pathwave System Design is that you can do everything from the same development environment. You just replace one block from simulation to actually say, I want a real signal generator, right? And in here, what we are comparing, in this case with hardware in the loop, is a traditional receiver. In this case, it's a very simple one. It's a minimum square error, right? And we also develop ourselves in Keysight, a machine learning model for doing the channel estimation. Not that we have the business in that, but just to understand the challenges and help our customers better. And finally, we have the model from InterDigital that they were training in simulations, and they wanted to know how we perform in the real life, right? And that's basically the performance. You see a game with respect to the traditional, and of course you also see a game with respect to our basic model. And the message is that yes, it works. You can actually validate it with hardware in the loop, and the channel estimator is able to compensate for the channel and give you the signal that you want.